we need first just to have this explained, this basic technology explained. So, Marty, we'll start with you. The BMI is building upon a former technology. Tell us about BMI and what was the technology that was originally being used to measure the ore and the waste and how it worked, and now how the new tech is working.
Of course. Let me start with the old technology. So this is the old technology, which is still applicable to the today workflows and today problems. What it does is you plant it pre-blast, and then you find it post-blast, right? As a result of this detection, you can easily measure how much ore body moved as a result of blast, and instead of randomly mining material, you go and do targeted mining. You find ore and mine ore. This has been the industry standard to measure movement for many, many years.
Yeah.
Still, it's the only solution in the market that directly measures the movement.
Right.
But through engagement with our customers over the past 2 decades, we learned about limitations and certain new requirements that this doesn't provide and doesn't meet. As a result of that, we started development of this new solution called Blast Movement Intelligence, or BMI in short, to address some of the limitations of the old technology and provide 2 options basically to our customers to decide what they want to do. If they want to do accurate direct measurements, BMMs are still the solution they need. If they are fine with estimates, they don't need accurate measurements and estimate meets their requirements, they go with Blast Movement Intelligence, which is an AI-based solution that you don't need to go and do direct measurements using AI. It gives you a good estimation of how the ore body moved as a result of the blast.
Right. Can you just explain a little bit for some who may not be fully aware of it? That looks like a little rubber ball. It doesn't look like technology, right? So how does this work?
So you pre-blast when you drill and put some explosive to blast the bench, right? You drill a few more drill holes and plant them in, right? You store their initial location. Once the blast happened, you go on the muck pile and look for these balls, right? These balls emit signals, right? Low frequency signals, so that you can detect them if they are buried down in the muck pile.
Right.
So by detecting those signals, you can find them post-blast. You know the initial location, you know the final location. You can easily interpolate where the ore body moved as a result of the blast.
Right. Okay. And this has been used, as you say, for many years, right?
Many years. Still, it's being used at many sites across the globe because there are some customers that are mining, for example, narrow vein gold. There's a very narrow vein of material that they mine, and it is very important to them to fully understand where that gold or material moved to.
Right.
And this is the solution that offers them that level of precision that they need.
Right. And Alexis, tell us about using this technology in practice, in the real world. What's your experience?
Well, like Maddie said, this has been kind of an industry standard. If you wanted to measure blast movement, we'd be going into our drilled patterns. We always add a couple extra holes so that we can actually install these. And it's a great technology. We are still using it in practice right now.
Right.
But there are certain situations where we're just not able to actually do the installation and drop these sensors down the hole due to safety instances and things like that. So I still think these BMM balls or sensors are still a great technology, and they can be used in conjunction to what we're about to talk about with regards to BMI.
Yeah.
But we have our geology team going in and installing it and finding it after, and so it's still been a great way to understand the ore and waste separation when we're about to mine it, so we can tell our operators where to actually go.
Right.
So.
Right. Okay. And what is your experience with the BMI so far?
Yeah. So as I mentioned, there are instances where we're just unable to install these balls due to constraints, or we're worried about the safety of our ore control personnel due to ice, snow, and whatnot. So this has actually allowed us to get out of the field a little bit, lower the risks and the hazards involved with walking around in the drill pattern.
Right.
And actually get a better understanding of what material went where in much, much finer detail.
Right.
And so that's, we're seeing so many different possibilities that we could use with BMI, not just increasing our safety, protecting our people, but trying to increase our productivity by better delineating our ore and our waste material.
Right.
So, yeah.
Right. Madi, I understand that the BMI technology is able to learn.
Yes.
But I'm not clear on what that means exactly. How does the BMI technology learn, and what does it learn?
So BMI technology, at its core, there's an AI model,
Yeah.
right? And any AI technology, it works when it sees and trains with data.
Yeah.
So with BMI, we have a pool of knowledge, pool of data that we collected over the years across multiple brands, across multiple customers.
Right.
And having that pool of data, that knowledge base, helped us to train an AI
Right.
that knows the dynamics of blasting and can provide a good estimate of how a specific blast with a specific design move the material after the blast,
Yeah.
basically.
Yeah.
Yeah.
That's very insightful, because it actually connects to something we talked about this morning here, which is this type of technology is great, but it requires enormous amounts of data to be useful.
Yes.
So you had the enormous amounts of data because you'd been using the BMM technology for years and years and years all around the world.
Yeah.
Okay.
So for BMM data is important, but for us to better estimate the movement, we need other data as well.
Right.
So in addition to like BMM data, we had to work with other customers to get some other data on top of the BMM data. For example, drill and blast data,
Right.
which is one of the inputs to BMI, or pre and blast topographies, right?
Right.
So those data, and like these data sets, they are not available right away because they are very specific data set.
Right.
That's why we started the journey a long time ago, right? So we went through a process of only collecting the data, experimenting with AI, and as we got to the point that the data was sufficient and gave us generalizable result and more accurate estimation, that was the time that we concluded, hey, this AI is good enough to enter the market, and that's how we brought this solution to the market.
Yeah. And you mentioned, Alexis, the improvement or why it's useful to use the BMI technology where you're worried about safety and things like that. But can you tell us a little more about that, how it works, any experiences you might have had in the company?
Yes, and maybe I'll start back to, while we were using the BMM balls, and when Hexagon kind of reached out to us to do a little bit of, early adoption and trying to test out this technology, where we had one of our ore control personnel who was walking on a muck pile. That means post-blasted material.
Yeah.
And it was, it's unconsolidated. It's a bit of a mountain. There's snow involved since we're in northern Canada.
Right.
And she did take a fall, and she wasn't injured too badly. But again, this is something that you hear in the industry. People do fall on muck piles. So that's kind of where we were like, okay, we should take a look at this technology, and then see if we can avoid getting into this kind of situation again, especially during that icy time of the year. And then working with Hexagon to try and understand better
Right.
Where did this material go? If the blast happened to fall over in the bench below, sometimes that's a black hole. We're not sure where exactly that material went, and it's hard to track the grades and the tonnage of what actually fell down. And with blast movement intelligence, we have a much better idea because of the inputs, a pre and post blast topography, where that material landed, where did the grades actually go, and that's just another aspect or advantage that I'm seeing from doing all these testing, and now we're able to actually keep track of that material. So,
And what about a related issue, which is the reduction of waste? How does it help?
again, if we don't take into account blast movement and we just provide our operators with no data, not even a BMM ball or BMI, there's always the possibility that we send our operators to the wrong area. An interesting test that they had done for us when they were on site with us is understanding how far these blasts can really move. And yes, it goes back to drill and blast practices, but there's still a possibility for some of your material to move, 5 meters, 10 meters. And in that particular testing, there was some material that had moved 20-something meters. So it is significant in some sense. So if we can really hone in on where that ore material is, then we can just send our operators to actually mine in that area. So that's when we're starting to do a little less. We get much less ore loss and dilution if we can really pinpoint where our material went.
There was a brief mention earlier that Centerra was early in this technology. Matti, can you please explain what was the team about? What was the consideration in the two companies working together, and what did it help you do?
So this is a very standard practice in product development, right? So when you introduce a new product into the market, you want to make sure that it actually solves a market problem, right? And you want to make sure that the solution you bring to the market is applicable to the problems that our customers potentially have, right? So getting that early market feedback, it was invaluable for us. It helped us to shape our product, shape the workflow around that product, and bring the right product to the market at the right time. We were looking for potential early adopters and development partners. The timing was perfect because they were looking for alternative solutions as a backup because of the incident that Alexis talked about. And we had that solution that we wanted to test. That's why how both companies came together, and we came up with a plan to test this solution and work together. And the benefit that I think Central Gold and Mount Milligan got from engaging with us early in the game was the fact that they had a direct impact on the way that the solution is today and will be in the future.
Were you involved in this from the beginning, Alexis?
Yes, and again, being in the technology space previously as well, it seemed like a good partnership because we'd already been using the original generation of blast movement, and we had all that data in a database, all the years of vectored movement, which helps to feed the model that Matti was talking about. So there was a lot of data already fed into this model for BMI, and it just seemed like a good fit, especially in the case, we were looking to be able to get more blast movement data a little easier, a little less risky, and even times where we're just not able to install it, we can do it a lot easier and a little bit more hands off, or off the field at least.
Matti, something we've been talking about in all of these panels today is asking, well, what do you see in the future? What is it going to be like 5 years from now or 10? But it's especially interesting in this case because the BMI technology learns from more and more data, And so it is going to advance clearly. And the question then is, okay, like 5 years of this, what's it going to be able to do?
So the technology is getting smarter, like as a whole, smarter and better over time. With the introduction of all these new technology from ChatGPT or other technologies, the advancement is ramping up. Specifically talking about blast movement is just one part of the overall value chain in mining. One small part of mining value chain, and there are other pieces of the puzzle as well.
Right.
So this our AI, as it gets better, it will learn from other data that is available in that we collect and is available through mining workflows. By bringing in other data points into the process, we will be able to solve much more complicated problems, delivering high value to our customers, and also do high-level optimization to ensure, like, to bringing more efficient mining and more responsible mining to the market.
So what you're saying is, it's not just that the technology will get better at what it's doing now. It will be able to do things it cannot do at all yet.
Absolutely.
Yeah.
Absolutely.
Yeah.
Very impressive. What do you think about that?
I agree on all fronts with Madi, and I think also having some of this data, general grade data, where this material this could be fed back to other systems, whether that's the drill and blast side of things, or we can correlate some of the data with our fleet management system to see what might have been planned, what we actually did, and we try to better our practices that way. And maybe there's going to be some sort of feedback loop at some point. I know they have lots of different ideas of what this data could potentially do, not just from a blast movement standpoint.
Right. Well, I'll tell you, at this point then, I think it's time for us to have the tech talk from Madi, because he's going to go into deeper, let's say into more depth than we have been able to do right now. So, Alexis, you and I are going to get off the stage, and Madi, take it over.
Thank you. After serving the mining industry for more than 20 years with our blast movement solution that we just talked about, blast movement monitors, I'm very excited to introduce the next generation of our blast movement solution at this venue. I'm Madi Yousefi. I'm a senior product manager at Hexagon Mining, and today I will talk about our brand new blast movement intelligence. Grade control geologists spend a lot of time and effort to come up with the most accurate grade control block model. And then they hand it over to drill and blast engineer, and they do what they do best. They blast. So after the blast, the first question that a grade control geologist need to deal with is where the ore that I spent a lot of time define the grade and all the information associated with it, where did it move? And how can I find the material that I'm interested in and send it into processing to recover the material that I want to mine? With blast movement intelligence, our mission is to help you to minimize your ore loss post-blast by enabling you to track material through blasting. At the core of blast movement intelligence, or BMI, there's an AI engine that is validated against measurement, and it gets better and smarter over time. The output of BMI is muck pile block model, which is a post-blast representation of your grade control block model with a 1 cubic meter resolution. This new block model retains all the attributes and items from your original grade control block model, and also it conserves mass from pre-blast to post-blast. And yes, we heard you. We know that despite the importance of measuring a blast movement directly, we know that in certain scenarios, deploying blast movement intelligence, deploying blast movement monitors is not possible. Or in certain countries, walking on a muck pile to detect these balls is illegal. This is why we introduce blast movement intelligence that give you an estimate of the movement without the need for walking on a muck pile, offering much less risky operation. So BMI's AI engine processes pre-blast topography, grade control block model, and drill and blast data, and generates muck pile block model that I talked about. This AI, our AI, has been trained with thousands of data points that we've collected over the years from multiple thousands of blasts. But independent of how accurate or how generalizable our AI is, how can you trust an AI and make decision based on an outcome of an AI when your decision has multi-million-dollar implication? This is the reason with every single blast, we validate muck pile block model against topography measurements. And if there is any discrepancy between the two, our AI fine-tunes the muck pile block model to ensure that it completely complies with the topography measurement. We also go one step further. We also validate muck pile block model against direct measurement using our BMM balls. We offer this service at the time of deployment and whenever it is requested. And also we recommend this level of validation because not only it helps us to gain your trust, but also it helps us to train the model using your own data to create a site-specific model that compensates for site-specific uncertainties and variabilities. And we are offering all these validation with one goal in place. We want to dispel the perception that AI is a black box by offering you full data transparency. Blast Movement Intelligence offers a very intuitive and user-friendly user interface. Also, it is the outcome of BMI, which is muck pile block model, is compatible with any geological modeling software that you use at your site. These features makes the deployment of the product, this solution, very fast, and it requires minimal training to get started and to use this application. And despite the sophisticated AI engine behind the scene, instead of waiting half an hour or so to get the outcome, BMI processing time is amazingly fast. For an average blast, it takes 5 to 10 minutes to get your output, which is muck pile block model. BMI is also integrated with Hexagon Block Model Manager. Block Model Manager is like a OneDrive for your block model data. It tracks changes. It allows for version control so that you can restore old version of your block model, old versions of your block model. And it also significantly reduces your data footprint by offering a very performant file format. But when you integrate Block Model Manager with BMI, there are new opportunities that are unlocked, which are unique in the market and unmatched. And today I'm going to talk about one of these synergies, which is the ability to lineate across multiple blasts. Let's consider this example. We have two adjacent blasts. The blast on the right goes off first. Using BMI, we generate muck pile block model, we draw dig polygons, and start digging. In this example, green represent waste, purple and pink represent ore. We start digging, but we don't manage to clean up all the waste before the next blast goes off. Next blast goes off, and some of that high-grade material goes on top of waste. The problem that a grade control geologist need to solve in this situation is, what should I do with the material that moved on top of the waste from the old blast? Is waste enriched enough so that I should send the material to processing or a stockpile, or it is not interesting, the material there, I should still send it to the waste pile? What Block Model Manager enables you to do is to merge and consolidate two or multiple mock block models and create a single block model. And because you have all the information you need, you can make a much more informed decision, not only about the material in this region, make much more informed decision across multiple blasts with a single block model. We know that BMI will slightly change your grade control workflow. This is why we have designed a customer success program to help you with change management aspect of the product adoption. In the first step, we're gonna work with you to understand your existing workflow and how you do your grade control and how BMI would impact that workflow. We're going to work with you, analyze the new workflow from different angles, and if there are any concerns, we will address those. Once the new workflow is defined and reviewed, we come to the site for on-site implementation and on-site training. Our goal with on-site deployment of the product is to ensure by the time we leave the site, all the end users know how to use the product, and all the end users know how the new workflow works. But our journey doesn't end there. We remain in touch. We remain connected after we leave the site. We will hold regular calls after we leave the site, and we will work with you to ensure that you adopt the new workflow, and if there are any questions or concerns along the way, we will work with you to address those questions. Despite the fact that mock block model is a new concept in the industry, there are more than 13 customers across the globe that are using and benefiting from mock block model. Mount Milligan from Central Gold has been one of them. They have also been one of our good customers, one of our good development partners in bringing this solution to the market. I think all of you attended the previous session that I spent with Alexis Ipen from Mount Milligan. And in that session, Alexis talked about her experience with the solution and how BMI has changed and going to change their existing workflows and what are the benefits they are getting from them. Thank you very much for listening to my presentation. Thank you very much.